Peace, y'all. So right now, I'm pretty much just about to go through the notes that I took from class and just get more familiar. See if I can get some further understanding and develop any questions for class later on today. Today I also have a nutrition test I gotta take for one of the jobs I applied for, which should be interesting because I haven't studied nutrition since I was in college. Now it's like 4 or 5 years ago now. Yeah, but I'm excited nonetheless. We're gonna make it work. Alright, so pretty much from what I do remember from class the other day, we started out talking about soil aggregates and how soil is made up of different pieces, I guess, that come together to create the soil. The more aggregates or the more pieces that you have, kind of makes a better soil. Let me see if I can find my notes. And I also did just get a new notebook too, so I'm going to be copying my notes into the new notebook. Okay, so in class, we had a representative from Understanding Ag come out and talk to us about soil health. So there's 6 principles. I think there were 4, but his organization added 2, right? So it says 6 principles of soil health, 3 rules of adaptive stewardship, and 4 ecosystem processes. So the 6 principles is 1, know your context. Our soil health practices are a reflection of ourselves and our stewardship of the land. Okay, by know your context, what I understood in class just means pretty much know what your soil has, know what it's lacking, if it's lacking anything. When we talk about soil, we're looking at 3 main categories, which is clay, sand, and silt. Usually, that's how they classify them. Alright, so what I'm going to do is crack this computer open so that way I can look a few things up. Alright, peace, y'all. So I finished up going over my notes for day 1, getting ready for day 2. I just figured I should run through what I learned in day 1. So day 1 was pretty much all about soil health, how to build it, how to maintain it, just different things that we can incorporate. So I'll share some of my notes. Talk about the soil microbiome and how important the soil microbiome is to how plants get water and nutrients. Talking about how there's a balance between dry and wet. Talked about soil aggregates, different things that make up the soil and the soil's compactness or the soil's structure. Some of those things are the microbiome, which has to do with like bacteria and fungi that grow and enrich the soil. That happens through mycorrhizae, mycorrhizae, mycorrhiza. So a healthy microbiome includes bacteria, fungi, and viruses, blue-green algae, and protozoa. Okay, but we talked about in the class was fungi and how mycorrhizal fungi help build the soil, and mycorrhizal fungi pretty much are located in the rhizosphere, right? Right. So mycorrhizal fungi are located within the rhizosphere of the soil, which is pretty much the immediate surrounding of the soil roots. One thing that they do is they help build the nitrogen access in the soil because plants are able to pull nitrogen from the atmosphere and they store them in the roots at places where these mycorrhizae fungi infect the plant, and where they infect the plant at the roots develop notches, and in those notches is where you'll find stores of nitrogen that are able to be released into the soil. And I thought that was cool because that almost sounds like a scab, like how you did a cut and a scab develops, and that scab allows for I don't know, I just felt like it sounded like a scab. Yeah, so that was emphasized the importance of mycorrhizal mycorrhizal. Okay, mycorrhizal fungi. Right, they establish a partnership with the plant roots, as I just explained. You also have other fungi, such as saprophytic fungi, which help decompose organic matter in the soil. So again, in a healthy microbiome, you have bacteria, you have fungi. That bacteria also helps with organic matter breakdown and nutrient cycling. You got viruses, which help do the same. Okay, one thing that we did not discuss that I did look up was you also have actinomycetes. Actinomycetes, which are filamentous or thin thread-like bacteria, which produce the enzymes for organic compound breakdown, and they're important in the soil structure. So actinomycetes are important in soil structure. We also talked about blue-green algae. Okay, so the thing about the exchange of nitrogen and how nitrogen is accessible to the soil as it happens in the exchange. So the soil, so the plant produces carbon sugars, right? And then the blue-green algae come along and they use those sugars for energy and they return nitrogen to the host plant. So the blue-green algae must be a form of mycorrhizal fungi. So blue-green algae is photosynthetic microbes, right? Mycorrhizal fungi, which fix atmospheric nitrogen and make it available to the plants, which also contribute to the soil stability. So exchanging plant carbon sources, which is sugars, right? Plants produce carbon-rich sugars, and those mycorrhizal fungi that surround the plant roots infect the plant roots. When they infect the plant roots, they're able to take energy or take the carbon, which they use as energy, and they return nitrogen. And that's called biological nitrogen fixation, or BNF, biological nitrogen fixation. Okay, we also got to see a slake test where he showed examples of two different soils. One was a lot more dry, one was more moist and had more structure. And the slake test is where you pretty much just insert them into water and allow time to pass and watch them dissolve. So there's three main categories of soils, which are silt, clay, and sand. Okay. Sand is very tiny, porous. Silt was tiny and porous, right? Clay is more compact and dry. Soil is bigger than sand and clay. It may also even have like rocks and debris in it. We also talked about glomalin. Glomalin is a sticky something because gloma is almost like glue, so it's sticky. So glomalin is an important part in aggregate stabilization, which is beneficial for mycorrhizal fungi. Talked about the rhizosphere already. Okay, and then we also learned about like 6 principles of soil health. On the bottom layer is context, which pretty much has to do with what's already in the soil, what minerals are there, what it's being used for, what it's going to be used to produce, right? So that's on your base layer. The layer above that Now these are principles. The principle above that is to not disturb. Do not disturb. You don't want to disturb your soil. You want to allow your soil to do its own thing naturally. Let me see. So yeah, you want to reduce the disturbance. Once you're able to reduce the disturbance, then you provide armor. And armor is going to be things like different plants, different covers that's going to protect the soil. When you have bare soil, it allows for moisture to escape, keep making the soil hotter. And when it's hotter, microbes or microbial fungi begin to die off. Anything over 140 degrees, not good. I think ideally, he said you wanted like anywhere between like 70 and 130. Oh, and another thing about that is how do I say? It's almost as if like water brings more water. An example of this would be like a rainforest, right? Where the rainforest is always wet. There's lots of moisture in the rainforest. So as soon as the clouds come over the rainforest, boom, they drop in water right back in the rainforest. That water is being cycled back up into the rainforest. But when you have bare soil, and you can think about a desert, water rarely comes down, right? There's no soil in the earth, so there's nothing to be brought up and dropped back down. So a way to bring in more water is to already have water in the soil, or make the soil available for water to be stored. What else? So above the armor, then you have diversity. So once you got your context, you stop. You got your context, then you stop disturbing the soil. Once you stop disturbing the soil, then you add the armor, or make sure you have armor, which is just maybe cover crops or things to protect the soil. In providing that armor, then you're going to have diversity, and diversity can be in a range of different plants or plant types. What else? In a range of different plant types, which leads you to the next layer. Well, let's talk about diversity a little more. So the diversity of plants, right, will encourage the diversity of microbes and insects and wildlife, right? Even up into the livestock. Nature itself does not grow monocultures, so why should we, right? That's what it says. So by having a range of plants, it's going to be healthier for your soil. It's going to bring in more insects, different nutrients. Those nutrients or those plants will be able to develop a network, exchanging what nutrients they have. So after you got your diversity, the principle above that is then keep living roots in the soil. Keep living roots in the soil, right? So as long as possible each year, roots feed the soil microorganisms which feed our plants. And that's what we talked about, the mycorrhizal fungi and how they interact with the roots, which builds into the mycelium network. So once you're keeping the soil alive at the top layer, or the sixth principle of soil health is grow healthy animals and soil together. So they emphasize utilizing different animals to help build the soil, and they do that by just allowing them to graze. But we talked about the difference between continuous grazing and what did they call it? Continuous versus adaptive, right? So continuous grazing is when you drive through California and you see these acres on acres and acres of open land where it's cows sprinkled in and they just kind of roam and graze as they please. This is actually destructive to the earth because since they have such a vast amount of space to graze, they do what's called selective grazing, where they go out and they pick and choose, they do the pick and choose thing, right? Where they choose what they want to eat and they leave what they don't. Just like your mama said, like, you need to eat all the food on your plate, not just what you want. Yeah, and opposed to that's opposed to uh, adaptive grazing, where you have a more concentrated amount of animals in a smaller space, right? But you keep them there for a shorter period of time, like maybe a day. But since it's a larger amount of animals in a smaller space, one, there's more competition, so they're going to eat what's available. And once they eat what's available, they're going to urinate and defecate, which is adding, what's the word? Well, they're going to urinate and defecate, not compost. I forget the word they use for poop. But anyways, they're going to urinate and defecate, which is going to add more nutrients back into the earth. But then since they urinate and defecate there, then it's going to be time for them to move, because they don't want to, you wouldn't sit in their own filth. So after they eat, they defecate, they urinate, and they move on. So when they move on, they leave this space alone, allowing for the space to regrow fully. Yeah, so you can definitely utilize that. I'm sure we'll be utilizing that. By moving the herd or moving the group, whatever type of animals you have. Just by keeping them moving. Yeah, so those are the 6 principles of soil health. Again, I'm gonna run through it. At the bottom, you gotta know your context, right? What are you growing? What's already there? What's available? Above that, once you know, okay, now you're not gonna disturb it, right? When you see nature, there's no mechanical disturbances. You don't see a bunch of machines or anything digging into the earth for any reason. So boom, context, don't disturb. Third layer is once you're not disturbing, then you're gonna cover and give armor, right? So you're gonna do what you can to protect the skin of the soil, right? Which is gonna help with temperature, which is gonna help with microbial life. Once you begin to do that, then you're gonna mix it up and make sure you got a diverse range of plants, which is gonna bring in a diverse range of insects, which is gonna bring in a diverse range of concentrated nutrients. So above that, after you mix it up, now we're gonna keep those living roots in the soil, keep them in the soil. We're not disturbing them. We're just allowing them to build. And once we got the living roots in the soil, then we can bring in the animals to do their thing. Yeah, so by doing that, we're gonna grow healthy animals and soil at the same time. Okay, what else did we talk about? I think I pretty much hit most of it. We also talked about how um, you can actually selectively choose what cover crops you want to plant as a tool. You use them as a tool. Some plants might provide you more nitrogen. Some plants might be better for this or might be better for that. They have what's called a cover crop periodic table that you can check out that will kind of show the benefits of different cover crops. Yeah, man. So I think that's pretty much hits everything that we talked about. Yeah. So like I said, using the cover crops as tools, aka service crops. Yeah. So that was week 2, day 1 of class. Thanks for rocking. Peace.